All right, so today we want to look at some counting techniques. So, in many of the examples, it is easy to determine the number of outcomes. You remember that if we have got an experiment, a sample space is a set of all possible outcomes. And then for you to determine an outcome in an event, in an experiment, we call that an event. So to associate probabilities with event, it is important to know the number of outcomes both in an event and in a sample space, and then you apply certain rules for your calculations. For example, we have got the multiplication rule. So if an operation can be described as a sequence of say k steps, the number of rows of completing step 1 is say n1, and if the number of ways of completing step 2 is say n2 for each way of completing step 1, and if the number of ways of completing step 3 is n3 for each way of completing step 2, so and so forth, the total number of ways of completing the operation is then given by the product of number of ways of completing step 1 times number of ways of completing step 2 up to and so on up to kn. So in the design of a casing for a gear housing, we can use 4 different types of fasteners, 3 different bolt lengths, and 3 different bolt locations. So for the multiplication rule, we have got 4 different types of fasteners and 3 different types of bolt lengths, and then we have got 3 different bolt locations. So we have got 4 times 3 times 3, which is 32 different designs which are possible from that design experiment. And then permutation. A permutation is a way of counting the order of elements. So permutation focuses on the order of a sequence, not rather than just getting elements. You are also looking at the arrangement as well. So permutation, you are not just looking at how computers are in a sequence, maybe in a computer lab, but you're also interested in how are they, the sequence and the order they appear in the sequence. For example, if you have got A, B, C, and then you have got A, C, B, and then A, B, A, C, B, C. So those are different permutations that you can get from 3 elements A, B, C. See, so permutation, you are interested in the order of the sequence of elements for that sample size. So the number of permutations of n different element is given by n factorial. This symbol is called n factorial. And n factorial is given by that formula where we say n factorial is n times n minus 1, n minus 2, and so on. So what would be 4 factorial? What is 4 factorial? 4 times 3 times 2 times 1. So that's 4 factorial. So this is the formula for computing permutations. Permutations has to do with the order in which things appear in a sample space. So the formula is given by p to the power n and subscript r, which is equals to n factorial everything over n minus r factorial. At least we all know how to compute those factorials. And then a combination is interested in the number of subjects of other elements that can be selected from. So a combination, we are interested in the number of subjects, not necessarily, or the number of subjects of selection of n elements. So here order is not important, so every subset of other element can be indicated by listing the elements in the set. So maybe let me give you an example. So if you have got I don't know how Zimbabwe number plates. Suppose you have got A, B, W, 4113. And then you want to look at, so this is your ideal number plate. So you have a car which has done a robbery, and the respondent, or what do you call, the witness, can only recall, let's say, these meager number. They can only recall these numbers, the letters, and the last digit. So they can only recall the letters and the last what? Digit. And you want to find different combinations of number plates that you should check for the car for the robbers. So you use you have to find different what? Combination of numbers to say how many numbers are possible, how many vehicles should I check with these number plates. So you are limiting your likely suspect in number plates using concept of combination. So the combination formula is given by n factorial everything over r factorial n minus r. So let's see some examples. Let's do some examples. So alright, so the following example, the design of a communication system considered the following questions. So how many 3-digit phone prefixes that are used to present a particular geographic area code can be created from digits 0 through to 9? And then, as in part A, how many 3-digit phone prefixes are possible that do not start with 0 or 1 but contain 0 or 1 at the middle of digits? And then this is just basic counting. This is just basic counting techniques. So this is just basic counting techniques that we did in the beginning. And then this is, are you interested in order, or are you interested in number of combinations? So the selection of elements. So how many digits can be prefixes are possible that do not start with this or this but contain 0 and 1? So this should be combination. And then how many digits phone prefixes are possible with no digit appears more than once in each? So this one is a combination of both. Alright, so let's look into the solution for that. So for the first one, you have 10 to the 3, so you want 3 digits that can be arranged. Remember, you are given digits from 0, 1, 2 up to 9. So there are 10. Your sample space is what? Is 10. So when we are picking 3 digits, so how many ways are there for you to pick these digits? So the first digit will be 10 times 10 times 10. So which is, we have got 1000 prefixes which are possible. So this is ordered sample without the B is ordered sample without replacement. So that will be, the first one will be 10, and then the second one will be 9 because this is without replacement, and then the third one will be 8. So that's what you get. And then for the last one, that will be multiplication rule, which is you remove the 2 digits. So let's go back to the question and let's, how many 3 digits? So you have got 3 digits. So you want to complete this 3 digits, and then possible with which no with in which no digit appears more than once in each. So this one will be how much? I mean, so for the first one, we can simply say this is 10, and then you choose one from here, and then the digit should not appear not more than once. So the digit that you have selected here should not appear again here and there. So how do we determine these values that are supposed to go in our multiplication rule? I'll give you a hint on how this 2 is calculated. I'll give you a hint of how. Clearly, you can see where this is coming from, or you can reason where that is coming from, and we can see where this is coming from. Huh? But this one, you have question marks. So try to apply the permutation and combination in this. Try to apply the permutation and combination formulas in this to determine this value. So try to use NPR and CPR. So first of all, you need to decide which one fits in this, because you know if initially you have strictly 10 digits, and then from this you have got 2 digits that you remove, and then the last digit is determined by what? Is it determined by permutation, or is it determined by combination? And then you calculate that value there, the number of ways of selecting the last one. So it should give you 2 should come from there.